In this course, we also talked about describing numerical data. We first talked about describing categorical data, now we move on to numerical data. Many of our variables are numerical rather than categorical. So numerical data, such as age of a respondent, income, measured in thousands of US dollars, or thousands of euros. The point is that with numerical data, it makes sense to add and subtract. How can we describe numerical data? Well, we have lots of measures. With categorical data, we really focus on proportion or percentage or counts, but with numerical data, we also have measures of center and location, other measures of location such as quartiles and percentiles. We also have measures of spread or variation such as the range, variance, standard deviation, and the interquartile range. So we really have quite a few ways of describing numerical data. The key point here is that we really have some measure of central tendency. Where's the kind of center of the distribution of some numerical variable? What's the average or what's the typical response? Then we might also have some spread. How far are spread out are these different observations? And then we also have other measures of location, such as percentiles and quartiles. So let's look at a mean from a sample. This is how you calculate the mean by hand. You just take each of these values from some numerical variable, divide by the total sample size, denoted by lowercase n, and we call it x bar. That's the sample mean. You can also calculate the mean of a population if that happens to be a data set. Right? The notation is just slightly different. We have capital N, which refers to the total size of a population, and we use this Greek letter mu. Right? For population parameters, we use Greek letters. For sample statistics, we typically use Latin or Roman letters. Not always, but usually. We also have this measure of the median. This is another measure of central tendency besides the mean or average. The median is sometimes called the 50th percentile. In a set of observations, the median is the middle number, right? Otherwise known as the 50th percentile. The idea behind calculating the median is that you sort your observations, right? And when you have a set of n observations from some sample, if the number of the total sample size, if the number of observations, if that's odd, the median is just the middle number. Right? If it's even, if the total sample size is even, the median is going to be the average of those two middle numbers. A related idea is percentiles. So the median is the 50th percentile, but what about other percentiles? The 75th percentile? Well, a percentile is simply the value below which a percentage of the data falls. So the median is the 50th percentile. That means 50% of the data are below the median, 50% of the data are above the median. Well, what about the 30th percentile? Well, the 30th percentile is a value below which 30% of the observations may be found. In general, a percentile is just a measure of location or position of a variable's values on a distribution of a numerical variable. Typically, we will use statistical software to calculate percentiles because, believe it or not, actually calculating percentiles by hand can be a tedious task. So typically, we will use statistical software to calculate percentiles, if at all. A related concept has to do with quartiles. So certain percentiles are so commonly used and so commonly referenced, we call them quartiles. Right? The 25th percentile is the first quartile. The 50th percentile is the second quartile. And the 75th percentile is the third quartile. You can see that we can just kind of split up the sorted set of observations in terms of these percentiles into these four chunks, which we call quartiles. So we have Q1, Q2, and Q3. Sometimes you will hear people talk about a quartile 0 or the fourth quartile, less commonly. But just keep that in mind if you see those referenced by other people or researchers. Quartiles also have several other names to keep in mind. Sometimes the 25th percentile, sometimes it's called the lower quartile. Sometimes the 75th percentile, sometimes it's called the upper quartile. And of course, the 50th percentile, right, it's sometimes called the median. Right? A related concept besides measures of location has to do with the idea of spread, right, or variation in a data set. Now, how different, how spread out is a distribution for a set of numerical observations? Well, we have several options. Right? We can calculate the range. It's probably the simplest measure of variation or spread. It's simply the difference between the largest and smallest values. We also have a related measure, the interquartile range. Right? The problem with the range is that it's sensitive to outliers because it's based on the maximum and minimum values of a numerical variable. So we can use the interquartile range. It's simply the third quartile minus the first quartile. That is the 75th percentile minus the 25th percentile. It doesn't take into account all of your data. It only really takes into account the middle 50% of your data, but it eliminates those high and low valued observations. It's essentially the range of the middle 50%, with the idea being that it's going to be more robust, less sensitive to outlying values, either extreme values on at one end or the other end. Besides the interquartile range, or just the general measure of range, we also can calculate something called the variance. Right? The problem with both the range and the interquartile range is that they don't look at all observations in the data set, but you really want a measure of spread or variation that takes into account all of these different observations. Your total sample size for a numerical variable. Well, that's variance. Right? If our data set consists of a sample from a population, right, then the variance is labeled S squared. The idea is it's calculated by adding up all the squared distances or deviations from the sample mean and dividing by n minus 1. This value of n minus 1, right, why don't we divide by n? Why do we divide by n minus 1? Well, that's because we're dividing by the degrees of freedom. Right? The degrees of freedom we won't cover too much on the final exam, right? But conceptually it's an important idea because you will see it again and again. What is the degrees of freedom? Well, the idea is this. Sample statistics, they're calculated based on a number of values that can vary freely. Okay? We call these values that can vary freely degrees of freedom. In general, the degrees of freedom of a sample statistic, it's the difference between two quantities. Right? It's going to entail some, this measure of sample size, lowercase n, and then it's also going to entail the number of other sample statistics used in the calculation of the sample statistic. So if our sample data set, if it consists of a sample from a population, then the standard deviation is called S. Right? It's calculated by adding up the square distances from the sample mean, dividing by n minus 1, and then taking the square root. To put another way, the standard deviation of a sample is just the square root of the variance of a sample. And with that, we've covered the basic ideas about spread or variation in a data set.